this is pretty crazy. Yeah, so this is really exciting, right? This is the exciting thing, that you're doing this. Order of operation matters, especially in computation, but this thing right here is actually S21 of -1 times S31 of -1 times the original matrix A, and then this now is S32 of -2. These things have already happened, right? And then this is, what's crazy about this is now S32 of -2, and then this thing right there is actually S21 of -1 times S31 of -1 times B. Yeah, you can call me Jeff unless that makes you feel uncomfortable.
Because of that also, it would be better over there to put the -1 for the shear matrix of 3, 1 instead of C, yeah?
Oh yeah, because those are different C's, is that what you're saying? Yeah.
Because that's
Yeah, oh, all right. Okay, so now can you guess what we do?
we do the backwards.
Oh my God, you are so advanced. You want a job teaching linear algebra?
No.
You should do it. Okay, cool. So this is 8-1. What I hope, you've seen that, my son really likes that movie Coco. You seen that scene in Coco where the jaw drops down and the eyes go in? I did that once in Engineering 11, nobody did it for me, so I'm really hoping you're gonna see something. Okay, can someone go ahead and calculate what x3 is? Anybody see some gravity there? Yeah. It's called fabricated data, right? let's not be too impressed. Like, this is not real data. This is a standard day in my lab at Foothill College. I get perfect data. All right, so now what? The moment we know that, what do we know about that entry? Is it known or unknown? It's now known. Okay, so now we go to the next entry. So this is going to be 0.3 times the unknown value x2, which is the coefficient on the first order of t, right? Because h of t was going to be, so over there I'll go back and do that in a second. So now plus 1.89 times x3, and the whole thing's supposed to be 0.441. Now what? Yeah, well, we know how to do this, right? x2 is going to be 1 over whatever the diagonal entry of my matrix was going to be, 0.441 minus 1.89 times whatever that entry is. In this case, that entry is 4.9. Okay, so I suppose I should just look at this rather than doing it by head. And I love what Mike was saying. That's the exact point of linear algebra, that I don't have to do that thing by hand. Don't trust your bum teacher, right? Never trust a mathematician until you've confirmed that they're not a bum, and in which case, sometimes that's an unsolvable problem. At least it is for me, right? Okay, so I got that one. Anybody else get that one? Claim this thing is supposed to be equal to that. That's the claim there. If you had an algorithm coded on the computer that did backward substitution for you for any n by n, and then you just substituted that matrix in, guess what you could do? Push enter, and then the output would come, right? Do you see the benefit there? Yeah.
It's just a thought I had. I don't know if it works. Could we combine, if we did shear matrices, and we had each of the indices, like 2, 1, 3, 1, and just put all the numbers in all at once? Would that work?
We are supposed to take a break, right, at some point? Because you know what you just did, right? 5 minutes after the break ends, we will talk about that. Yeah, we'll get the, you're like a few steps ahead of me, right? Yes, that's right. And in fact, do you remember what Gauss transforms are? You remember we talked about Gauss transforms? Gauss transforms are just the shear matrices that are used to zero out any individual column. And really all you need is if you're, yeah, so say stop, Jeff. Say it's time to go to break in a second, and then we'll get there, right? Yeah, this is why I designed this course this way, right? Because then you're literally like hopping along, and by the next hop, you like have everything you need to the back end, right? Yep. Okay, so what's the last one? What's the last thing we want to fill in there? x1, and the claim about x1 was what? 1 times x1 plus 3 times x2 plus 9 times x3 was supposed to be equal to 3.000. So what does that immediately mean about x1? This is going to be 1 over the diagonal entry, take away the last or the first element of my vector b, and this would be 3 times 29.4, right? Minus 9 times negative 4.9. And then the claim of this thing is that x1 should be equal to, if I did my calculations correct, negative 41.1. Okay, so this is where I think it's really important to bring data into class, although I agree that this is fabricated data.